thank you very much for having me. My name is Johannes Gessner. I'm very happy to present my paper, Shifting Gears, Environmental Regulation in the Car Industry and Technological Change. Before I dive into the talk, let me quickly motivate why we need to talk about innovation. We talk about climate change mitigation. To do so, I brought a graph here from the International Energy Agency showing you the trend in global energy sector CO2 emissions and what they calculate should be the emissions development up to 2050 if we want to comply with the Paris Climate Agreement. That's quite a dramatic shift that's probably not news to anyone in this room. The more interesting bit is on the right-hand side, where they disentangle this reduction by technologies, look at what should come from technologies that are already adopted on the market and mature, what should come from technologies that are on the market but not as broadly adopted yet, and what should come from technologies that are currently in a prototype state. And you see that the bulk of this emission reduction really comes from technology where some innovation is needed. One of these fields we're going to talk about today is the car industry and electric vehicles. And when we think about innovation, we have to keep in mind the entities that are responsible for that innovation. In our setting here, I have a production setting with a disintegrated production process where you have manufacturers and suppliers, and they both account for a share of innovation. And so in the car industry, you have, when you look at the 15 most important innovators in that industry, you have roughly half of them being car manufacturers like Toyota and Hyundai that are producing these electric vehicles and that are regulated in the downstream market. But the other half of these large innovators, and actually also roughly of the innovation we see in this market, comes from suppliers that are not directly regulated, but they are producing intermediate inputs for these car manufacturers. And so the question that arises in this context is, what is the effect of this environmental regulation we have imposed on the manufacturers in the downstream firm, on the innovation upstream suppliers? I'm going to look at this question from two different angles. I'm first of all going to look at the innovation response of suppliers in response to changes in the regulatory stringency among downstream firms. And secondly, I'm going to look at the sourcing strategy of manufacturers in response to more stringent regulation. Do they source more from firms that already have expertise in cleaner technologies? So, the context in which I will do this is the European CO2 emission standard for cars, which regulates the fleet average emissions of all vehicles sold by a manufacturer. And I think two things in this paper are new. First of all, I provide causal evidence for the effect of exposure to downstream environmental regulation on supplier innovation. And secondly, I do so using a novel identification approach based on data that links manufacturer level stringency of regulation to supplier level innovation outcomes. And I'm going to talk about more details as we go. Yes.
So in principle, if you think about the climate problem, there's no reason why we should stop at the first link of the input supply. I mean, eventually, electricity production, particularly in Germany, has to be clean in order for this to have an effect on.
For sure. Yeah.
So I understand it's not operational in this case, but that seems like studying the reactions at the higher supply chain.
Yeah, that would be the ideal. Yeah. But I think this is an important first step to see how these effects actually locate up the supply chain, to just first look at one suppliers, and then you might expect to see smaller effects further up in the supply chain. I think this already. All right. Okay, so a quick preview of results. What I find is that exposure to more stringent downstream regulation increases innovation for clean technologies among suppliers, and I don't find much of an innovation response in terms of dirty technologies. I'm following the convention of this literature, looking at clean technologies related to zero emissions, technologies here, electric vehicles, and dirty technologies related to a fossil fuel-based alternative. Yes.
I have a question: how to define the clean innovation and dirty innovation?
We will do this in 5 slides. The bottom line is you have patent data where you see patent codes that identify different technologies, and so you can say a patent is relevant for electric vehicles or for others.
Okay, is there any neutral innovation?
Excuse me, neutral innovation.
For example, that the innovation didn't belong to the clean innovation or dirty innovation.
Yeah, there can be other things. I will have a measure for other things, and there can also be overlap. So if you have something that's related to a hybrid vehicle, it's probably somewhere in both classes. And the second thing is the formation of supply chain links. What I see here is that manufacturers subject to more stringent environmental regulation are more likely to source from innovating suppliers. And that seems to be driven by firms that have some prior expertise in these clean or gray technologies. Gray technologies is exactly reducing the emission intensity of the dirty alternative. Okay. Let me quickly go through the literature. There is a big literature already on environmental regulation and innovation in the car industry. What I think I add to this literature is the explicit focus on the role of suppliers and their innovation efforts for the overall picture. The second literature focuses on the innovation response of suppliers to downstream environmental regulation. There is a number of theoretical contributions in here, also by Eugenie, who's unfortunately not here today. What I think is new in my paper is that I try to quantify a causal effect of being exposed to more stringent regulation downstream, and I think this hasn't been done before. And thirdly, there is a literature leveraging these different scandals in the car industry to obtain identifying variation for different things. What my paper does is I'm using the Volkswagen diesel scandal, which I will introduce later, to obtain a shift share instrument for the stringency of this European CO2 emission standard. All right, with that, we can go into the context if there are no questions. Okay, we are talking about a fleet average emission standard. This is the European CO2 emission standard for cars. It regulates the emissions of the average vehicle sold by a manufacturer, and emissions are determined in type group tests. So you put a certain car model on the testing stand, you measure the amount of CO2 that comes out of it when it drives a certain cycle, and then you basically create a sales weighted average over all car models that are sold by a manufacturer, and that has to be below a certain target. Okay, unlike in the US, over-compliance with that target cannot be traded, and that gives you heterogeneous levels of regulatory stringency across car manufacturers. Regulation comes with emission targets. It's adopted in 2009, and basically the full schedule of targets up until 2020 is already written down in that first regulatory piece. And so you have these 5-year updates. The first regulation, I'm not sure whether you can see this pointer. So the first regulation becomes binding in 2015. That's a standard of 130 grams CO2 per kilometer. And then you have a much more stringent standard in 2020 with 95 grams of CO2 per kilometer. And all of that is anticipated, so manufacturers can work towards compliance.
And do the manufacturers report compliance, or is there?
Yes, that's the data. What you see here is fleet average emissions across 27 manufacturers that are regulated. Before 2015, so in 2015, this T15 target, over here, becomes binding. And manufacturers seem to work towards that goal. So nobody's compliant in 2010, and then in 2015, everybody is more or less compliant with that regulation. The same thing goes for the 2020 standard. And you see that there's heterogeneity, right? So there is a group of car manufacturers that just barely makes it. And there's others for which, well, this first target is probably less relevant, but still the regulation is binding for them because in 2020, they have to comply with this much more stringent target level down here. And
do they verify themselves, or is there a third party?
So they have to report these emissions to member states, and then they have to report to the Commission.
But who's checking that they're actually just correctly reporting?
Well, you can check with the sales data. I think that's not too complicated, and I think the Commission is in charge of that. So
When they run these tests, is there somebody from the Commission checking?
Okay, so the tests are a whole different issue, right? So I can only talk about what we see in the laboratory, fortunately, and we know that this is not good.
Yeah.
But still, in terms of this regulation, this will matter for compliance. And during this period, we see almost no non-compliant firms, but this changes after 2020, right?
I'm probably trying too much to think about the US case, but we should think of this as just about measured fleet level averages. There's none of these funny non-linearities with the flexible fuel loophole.
There's some of these funny non-linearities. Everything that is constant over time, I keep. Then there's some phase-in requirements. So you get something like a super credit in the years 2012 to I think 2015, but that shouldn't matter for this long-term compliance. Well, what I'm saying is that the manufacturer shouldn't take that into account when they think about being compliant with the regulation in 2020, right? So they want to reduce their long-term emissions, and so everything that is just there to phase in something shouldn't matter for them. All right.
Sorry, if you might further this on, but so should we think about this as they're introducing new models or they're like increasing sales of the more efficient?
They might do all kinds of things. This is a paper about suppliers. I don't really care too much. Okay, yes.
You might want to push back on them, but I see there's some very interesting thing happening in 2015. You see the consciously worked towards that objective, and then the 2020 objective is like 95, and it seems to be nothing after 2015.
Yeah,
Are you just going to kind of once in 2020?
You have King here, right, in 2017, and that I think is partially due to the measurement changing. So before we were using this new European driving cycle, and then you have WLTP coming in. I guess that's part of the explanation. The other explanation I'm going to show you in a couple of slides.
Right.
Okay. So with that, we can move forward to the first research question to look at the innovation of suppliers. To do so, we have actually to think about how suppliers are affected. Let me introduce that with an example. Think of two suppliers. This is actually data. One is an Austrian firm called Hirschmann. Another is a Japanese firm called Fujikura. They both provide wiring harnesses. So that's assemblies of cables for electricity transmission. Now, how are these firms exposed to the regulation? Well, in the car industry, we have persistent supply chain links. Hirschmann is providing components for two German firms, Volkswagen and Daimler. Fujikura is providing components for Toyota, Subaru, and Honda. And so whatever affects stringency for these manufacturers will affect one of these suppliers. Okay, so how do I think about this? We have a manufacturer level measure of regulatory stringency, which is simply the gap between fleet average emissions and the future target divided by the target, because there are some manufacturers with exemptions. And then suppliers are exposed to different sets of firms, right? So for Toyota, this is not very stringent. For Honda, it is. And how are they exposed? Well, they are exposed based on the car models J, for which supplier I provides at least one component, and that is sold by manufacturer O. And then I take a sales weighted average across all the models that the supplier provides a component for. Okay, that gives us these different exposure weights, and so you get a supplier exposure to regulatory stringency by simply calculating a weighted average. This is going to be important later on, because anything that shifts the stringency for Daimler, so that makes Daimler's cars more dirty, will just affect Hirschmann, but will not affect Fujikura, and that's the sort of variation that I'm using in this paper. All right. Quickly on the outcome variable, I'm using patent data as a measure of innovation. I'm using technology-specific patent counts here. I'm not really innovating. I'm relying on a previous paper to select CPC codes. That's the patent classification used in Europe and the US, to select patents that relate to clean technologies, which is going to be electric vehicles mostly, dirty technologies, conventional cars, gray technologies, conventional cars, improving the fuel efficiency of those conventional cars, and a benchmark technology, which is basically stuff related to the car industry. Okay, if there are no questions on that, I would move on for the sake of time. Yes.
Isn't there kind of an externality going on here, in the sense that, you know, an electrical car functions by combining a lot of different technologies, and you know, some components go better with others. It's like medicine, Rebecca Dick's work, you know, that. So you give a family of medicines to a cancer patient. So when you develop one part of that family, you know, internalizing that externality. So we've seen that there's similar things going on here. Electrical transmission goes on to, you know.
So there's technologies developed in another industry that might be relevant for electric vehicles. Is that what you're saying?
Yeah.
Yeah. So for electric vehicles, I think I have a better answer than for the other two classes, which is in Europe, we have this YO2T class, which is basically technologies relevant for climate change mitigation in transport. And there you have this cross-cutting across different fields, just identifying technologies that could be relevant for electric vehicles. So this also goes into electrical equipment, and we will see that some of the supplier firms here are originally electrical equipment.
But what kind of transmission you want to develop depends on the type of battery that you have in the car, and so there's a natural, and these are different manufacturers.
Mm-hmm.
Then there would be an externality effect that wouldn't be internalized by the single innovator unless they make a deal with their compatriot. I understand you're not dealing with it, but maybe a good thing to think about because, that's a major thing. It's an O-ring theory kind of technology, right? The word component designs or something like that.
Yeah. Yeah. Well, in the context of the single industry, there's other firms that are working together, sometimes for a very long time. So I think some of this is internalized, but you're right that maybe there's more to it. Okay.
Excuse me.
Yes.
Why do you group hybrid clean semi-electric?
Well, you have a lot of components like the batteries and all these connectors that are relevant for a hybrid and an electric vehicle. So to make it dirty wouldn't really make a lot of sense. The other thing is, if you think about these fleet average emissions, the rated emissions of hybrids are very low. And so, although they are probably used in many cases as a combustion engine vehicle, in theory, they are a tool to comply with this regulation. And that's what matters for my definition of clean technologies.
So you made the classification by yourself?
No, this is from another paper, but they are also
Okay.
working on EV technology. Okay, let me quickly walk you through the data. The patent data comes from PATSTAT. I think this is fairly standard. The nice thing about patent data to measure innovation is that you get an application date, so you can link it to a specific point in time. You get an applicant, that is the firm owning the patent, and you can classify patents as pertaining to different technologies. And so that gives you a good measure of innovation at the firm level. I'm using manufacturer supplier links from a company called Marklines, where I have information on components provided to different car manufacturers. And that measures the supplier exposure to different manufacturers. Then I link that to administrative data on all new passenger car registrations in the European Union. Basically, I use that to construct a measure of regulatory stringency at the manufacturer level. And finally, I link all the entities in these three data sets to Orbis to account mostly for ownership structures. So there are some suppliers that are owned by a car manufacturer, and I don't want to include them. There are some suppliers that are just huge conglomerates, and I want to make sure I catch every entity. Okay, that's, yes.
It's not to do with identification, but more in just thinking about generalizability here. What do you want us to think about the regulatory environmental sort of policy discourse that informs expectations of the regulatory environment for the suppliers upstream? I mean, I understand what you're using is variation downstream and how that's affecting them, but they're presumably not in a totally neutral regulatory environment with respect to clean versus dirty innovation directly as well.
Yeah, so I'm going to use an IV approach, and that should be
It's not identification, more,
Yeah,
we would expect different effects if they were completely left alone versus if there are other types of incentives and so on for.
Yeah, so that certainly moderates my effects. Say if there's other regulations.
But do you know what the kind of broader environment is in these types of electrical, whatever, the broad categories of suppliers at this time?
Yeah, I think there is subsidies for R&D as well. So that directly apply to the suppliers. I haven't looked at this into too much detail because what I'm using is variation in this downstream regulation, right? And there, I think the answer is that you're working with a pretty constant set of manufacturers over time. And so you can observe how this stringency of the regulation changes. The difficult thing is that typically suppliers would anticipate that change. Right, and so I'm looking at something that gives us unanticipated changes. Does that answer your question?
Sort of. I think it's not. I'm not asking it as a point about identification. We can talk about it afterwards. It's more about how can I think about how this might apply in a different set of supply chains, which is going to depend on. No, I take the point.
I agree with that. And we've seen that there are for policy discussion, if they're all EU regulation, and that's one thing. But if it's Chinese regulation and it's relevant for the suppliers, then it's a completely different one. So
yeah, this is only about EU regulation, and let me actually talk not too long about the descriptors, so we can get to the part where it's about EU regulation. So descriptors very quickly now. I have patent data. This is very heterogeneous across firms, right? The average firm applies for 49 patents, but there are some that apply for north of 1,500 patents. Others don't have a single patent in some year. Clean patenting is a slightly larger category than dirty patenting. So we are past this point where, think about patent dependencies driving us towards dirty innovation. For the average firm, we need emission reduction 3 grams, that's for manufacturers. The standard is mostly 95 grams, but there is some variation when you have a derogation because you're a small manufacturer. And then finally, the weighting here, the exposure weights give us an exposure to regulatory stringency that is similar to what we see in the market. It just has lower variation because most suppliers are working with more than one firm. Okay, so what I want to estimate is this model of a patent count for specific technologies on exposure to regulatory stringency downstream, controlling for firm fixed effects and supplier fixed effects. The way to go forward here is to use a quasi-differencing approach because that allows you to work with the sequential exogeneity assumption. What I'm using is an approach by Wooldridge, where you basically difference out these firm and time fixed effects. Now, the thing that's missing is an instrumental variable here because the exposure to regulatory stringency is of course endogenous. You have suppliers that provide components for a new clean car model. This will reduce the stringency, but at the same time increase supplier innovation. So we need an instrument to counteract that. And what I'm using here is this shift share IB. Let me just say I'm going to use exposure to manufacturers with different reliance on diesel technologies as the identifying variation, and let me introduce the model on the next slide. So the instrument. So we've seen this graph. When you take out the diesel cars from manufacturers' fleets, you see that the emissions are much higher, and so they were using diesel cars to reduce their average CO2 emissions. Now, this is just another graph telling you the same. When you have an advantage in producing diesel cars in terms of their emissions, you're going to sell a lot of those diesel cars in the market. So this is actively used as a compliance channel by manufacturers. And in 2015, we had this scandal on another air pollutant, which was NOx, nitrogen oxides, which led to a big reputation damage for diesel cars. In the aftermath of the scandal, we saw their market share dropping by 20%. And so that's going to give me the shock component for this shift share instrument. This is just the instrumental variable as a formula. So you have a time constant exposure weight of suppliers to different manufacturers multiplied with this manufacturer's reliance on diesel cars, measured as the stringency for the diesel fleet and the stringency of the non-diesel fleet. And then you multiply that with changes in the market share of diesel cars over time. This is the first stage. The F statistic is 44.3. This is an effective F statistic. So the instrument is reasonably strong. And that's all I want to say at this point. Let me quickly walk you through the results because I think I'm running out of time. I have 5 now, right? Oh no, we started 5 minutes late, so I have plenty of time. Okay, so then the sign on this instrument, I got confused. The sign on this instrument is a bit different from what you would expect. The reason is that these shocks at the manufacturer level are of course not random, right? So if I'm a manufacturer relying heavily on diesel cars, I will not reduce my diesel market share immediately. And the thing that we have to keep in mind here is that this shift share identification relies on exogeneity in the shares. So this isn't a problem for the identification approach. I'm happy to talk about details afterwards, I think. What we see in terms of innovation outcomes, and let me quickly walk you through the table. So the first line is always the variable of interest. I show you my first stages down here to be fully transparent. I have talked about this, I will not do it again. And then I compare an instrumented and a non-instrumented column. You see exactly the attenuation that you would expect given the reverse causality we've talked about. And now for the instrumented regression, we see that a 1 percentage point increase in exposure to downstream regulatory stringency leads to a 12% increase in the number of clean patents filed by a firm. That's quite substantial, but remember it's against the small baseline, so this corresponds to roughly 1.3 additional patents per firm per year on average. The second thing is gray innovation. I see some evidence here that there might be a reduction in gray innovation in response to exposure to more stringent downstream regulation. However, this is only significant at the 10% level, so I'm not going to interpret this as a cause. And then the final two are dirty innovations, so that's everything related to just combustion engine cars. I don't see evidence for any significant effect there. And I also don't find evidence for a significant effect on the overall amount of patenting, telling me that this is rather a story about reshuffling of innovation efforts than increases in overall innovation. Now, there's one concern that I want to address in the talk and further concerns that I address in the paper. Who is driving this increase in clean innovation? Is that a consequence of people shifting towards electric vehicles in response to the standard? To address that, I split the sample into suppliers that have an exposure to a low share of electric vehicles ex ante and a high share of electric vehicles ex ante. I don't see any effect on either group. And in particular, I don't see differences in the effect on these two groups, telling me that this doesn't seem to be what's driving my result. The other split is more interesting. I'm going to come to you in a second. When you split the sample into supplier firms that have prior expertise in these clean technologies versus those who don't prior to 2015, you see that the entire effect comes from firms that were innovating in clean technologies before 2015. So specialization really seems to matter. This is consistent with previous findings in this literature. Yes.
So on your proposed result that gray is negative and clean is positive, should we think about it as they will take the policy that's cheapest to achieve the objective, or like they have a given budget of R&D that is going to be climate focused, and depending on it, they will do R&D on one of these two?
Yeah, so the clean effect is sort of anticipated in the literature. That's exactly, it's a cheap way to reduce emissions if you just sell one that comes with zero emissions. The gray is theoretically a bit undetermined, right? Because on the one hand, you're reducing the size of the future market for dirty cars, for combustion engine cars with this regulation. On the other hand, making these cars cleaner is increasingly profitable. And so theoretically, this effect isn't really determined. And the outcome we see is that it's going to be reduced, probably the story that you.
I guess the result of that, so to the extent you have maybe some chance in Germany to have employer-employee data, you look at what happens to employment and which type of people are being hired on the extensive margin in connection with this. Supposedly, you have to find someone if you change direction of innovation that is better at that, or you have things already, as you say, but that might give some insights into how the adjustment happens. In Swedish data, it would be feasible to do. I don't know about the.
Yeah, I haven't really ventured into that because then you would need to assign innovators to specific technological fields. I know that this is possible.
Or do your education going to be difficult to do? What do you work before?
Okay, so to check whether
university or not.
Somebody with an engineering degree specializing in internal combustion engines versus somebody with electricity. Yes.
Do you also see the lag effect?
So this is the first lag. I'm also going to look at, because I only have one instrument, right? So I'm also going to look at a long difference over the full 5 years after the scandal. And I see a slightly bigger effect, but it's not much bigger, telling me that much of this is actually probably coming from the first lag.
I was wondering, going back to the previous question, how do the results change if we remove the hybrid vehicles from the clean classification? Because maybe if in the long run we care more about transitioning to the purely clean electric vehicles, the long run, maybe the policy might look to have a very positive effect in the short run, but maybe not that much in the long run if the two technologies are not
Something I
very
haven't done, which has been done in other papers. The problem is that the number of patents is already quite small, right? And the number of firms that are active is already quite small. So there's limitations to the power I have in this paper, simply due to the fact that I'm focusing on firms that are directly linked to this industry. Okay, I was told I have 2 minutes left, so I want to move on. This answers the first research question. For the second one, I'm going to be rather quick. So I'm going to look at a different data set where I construct a cross-section of potential manufacturer-supplier pairs in 2021 and 2022. Why that period? This is the next regulatory phase. These links in the car industry tend to be persistent. So if I have a more stringent regulation in the previous phase of the targets, then this is going to affect the link formation probably in the next period more. I'm going to regress a link dummy for whether or not two firms, a supplier I and a manufacturer O, are linked on the interaction between the manufacturer level stringency of the standard in 2019, so that is in the previous regulatory period, interacted with a dummy for whether or not this supplier has knowledge stocks in a certain technological field. Okay, and then I control for a couple of additional things, most importantly, whether or not that link was existent before or not. The object of interest is this coefficient here on the interaction, and sometimes I combine that with the overall beta zero. And let me just quickly go through this, and then I have the question at the end. I think it's better by now. This is going to be estimated in a profit control function approach. I'm going to use the reliance on diesel technology again as an instrument. The assumption here being that the scandal on relying on diesel cars doesn't directly affect the formation of future supply chains. What we see in the data is that more stringent regulation seems to increase the propensity to form additional links. Okay, very quickly, these three results, and then I'm done. But the effect is much stronger for firms that actually have patents prior to 2015. And among those that have patents, it seems to be driven by firms that have at least one patent in either clean or gray technologies. The effect is a bit stronger if you compare gray to non-gray than clean to non-clean, but due to this large mixed group, you cannot really disentangle it here. There's a couple of additional things that I have done, which we can talk about, but with that, I think I have to wrap up. The result is suppliers innovate more, manufacturers source from cleaner suppliers, and specialization really seems to matter. That have two implications we should take into account: spillover effects, and regulating final products might be sufficient to induce upstream innovation. Thank you very much.